Hello, my wonderful students and chemistry lovers. Today I'm going to talk to you about covalent bonding. My name is Dr. Lutano Kwesele, and I'm going to serve as your guide today in this interesting lecture and conversation. Okay? When you talk about covalent bonding, you are talking about atoms combining by way of sharing their electrons. And this is for them to attain what we call their octets, or for them to attain the stable electron configuration of the noble gases. And again, when atoms combine in this manner, what happens is that there is an attraction between the two nucleus of the combining atoms. Okay? So here is a beautiful example of what we call covalent bonding, where you have hydrogen atom combining with another hydrogen atom to make hydrogen gas or hydrogen molecule. As a matter of fact, what you have here is the Lewis structure showing that this has one electron in the outermost shell, and this, of course, have one electron in the outermost shell. When both of them bring their electrons each, they make what we call the shared pair or the bonding pair. And that bonding pair or shared pair represents what we call a single covalent bond. And that single covalent bond is usually represented by a dash. All right? So if you watch closely, you will discover that the atoms that are combining in these particular reactions are atoms of the same element, in which case two atoms of hydrogen. But in covalency, it doesn't just involve atoms of the same element combining. In some other instances, you're going to have atoms of different elements that are coming together to share the electrons for all of those atoms involved to ultimately attain the octet, or for them to have the stable electron configuration of the stable noble gases, as it were. I believe it's clear. So in covalency, it's not just about hydrogen combining with hydrogen. It is also about hydrogen combined with carbon, with oxygen, with other atoms in different proportions and in varying numbers as well. In some instances, you're not just going to deal with simple molecules such as methane, such as ethane. Sometimes in covalency, you talk about it being the attractive forces holding numerous number of atoms together in place in what we call complex molecules or complex biomolecules. There are certain chemical molecules that aid the function of our life from the cellular level down to the system, up to the system level. All right? You are talking about molecules like cholesterol that involves in almost all the metabolic reactions in the human and animal tissue. You are talking about things like DNA, deoxyribonucleic acid, which of course carry the genetic traits of individuals. And you're talking about proteins, which you know that proteins are key components of enzymes, all right? And many interesting molecules that sustain our life. I said all this to tell you that everything you see in life is held together in place by some kind of binding forces. Again, those binding forces could be ionic, like what we treated in the last series, or those kind of binding forces could be covalent bonds, as it is. You've seen both in simple molecules and, of course, in complex molecules. And you can attest to the fact that these molecules actually aid our lives. So that means that covalent bonding is a key aspect of what ultimately holds and sustains our life. I believe it's clear. You can see this covalency demonstrated by looking at the simple molecule of methane. You see carbon centrally placed with 4 covalent bonds joining carbon to hydrogen. Again, you see in ethane 2 atoms of carbon bonded together by a covalent bond. And of course, the covalent bond there, you see that 3 other covalent bonds holds hydrogen atoms to each of those carbon atoms. So again, when you talk about your cooking gas, You are talking about natural gases like propane, ethane, and of course, methane. All right. So these gases, you can see aids combustion. And of course, that what helps us to prepare the food. But for those gases to ultimately be formed before they are mixed to help us in our gas cylinders, you can see that some kind of binding forces joined in their creation. And this is important because, again, I say everything in life is held together in place by strong attractive forces. All right, from the cellular level to the tissue level to the organ level and even to the system level, using human beings as just an example. But even the inanimate object you see, some kind of attractive forces are holding their particle in place for you to have that the existence of whatever it is you are talking about. So you can see how chemistry helps us to now describe life. If that is clear, you will understand with me that there are two kinds of covalent bonding, essentially. There are two major types of covalent bonding. The first type is known as single or ordinary covalent bond, while the second one is known as coordinate or dative covalent bond. Again, the simple ordinary covalent bond is also subdivided into two subtypes, which is the non-polar covalent, or also known as homopolar covalent bond, or you are talking about polar covalent bond, which is also known as heteropolar covalent bond. Now we are going to take them one after the other and describe them briefly. All right? Beautiful. So when you talk about simple or ordinary covalent bond, you are talking about a combining of two atoms where each of those interacting atoms bring one electron to the pair, to the mix, or to the bond that is created ultimately. This is what we found essentially when we talked about hydrogen combining with another hydrogen atom. Each of them supplied one electron each to make the single covalent bond. Such kind of covalent bond where there is this mutual bond share, mutual electron sharing, each of them supplying exactly one number of electron each of them supplying one electron each to the bond is known as ordinary covalent bond. An ordinary covalent bond is of two types. All right? Ordinary covalent bond can happen within atoms of the same element or atoms of different elements. The first type is known as non-polar or homopolar covalent bond. This is a type of covalent bond that is formed between atoms of the same element, or what we call similar atoms. Atoms that are homonuclear in terms of their nuclear strength. Okay? We are talking about atoms of the same element, just like what we have here. Hydrogen atom has the same nucleus with this hydrogen atom. So the nuclear strength is exactly the same. All right? If that is clear, you see that another beautiful example is when you react chlorine atom combining with another chlorine atom to make chlorine molecule or chlorine gas. Beautiful. Of course, this brings one electron, as you can see. Okay. This brings one electron. This brings one electron and ultimately forms this single covalent bond. But if you watch closely on that covalent bond, I use two dots to represent the two electrons since each covalent bond carries two electrons. So I use that two dots, one above the bond and one below the bond, to represent the electrons coming from each of those combining atoms. Now, because chlorine atom and chlorine atom has the same nucleus or nuclear charge as it is, what happens is that their appetite for electrons is exactly the same. In which case, if they are pulling on the electron remains exactly at the center of the two combining electrons. The electron pair or the shared pair is not biased towards any of the combining atoms. This is because they are homonuclear. Their nuclear strength is equal. Why? Because they are similar atoms. Why? Because they are atoms of the same elements. I believe it's clear. Again, the second type of ordinary covalent bond is known as polar covalent bond or heteropolar covalent bond. Of course, this type of covalent bond is made when you have atoms of different elements combining together. So here we are talking about the combination by way of sharing of electrons between the similar atoms, or what we call heteronuclear atoms, atoms whose nucleus are different. So their appetite for electron will be different. Okay, a typical example for that is the reaction between hydrogen and fluorine. Recall, in ordinary covalent bonding, primarily, each of them is bringing one electron for the bond to be formed. So if hydrogen brings one electron, and of course fluorine, hydrogen supplies one electron, fluorine supplies one electron. So we have a single covalent bond there. Of course, hydrogen again, hydrogen requires just two electrons because it obeys the duet structure, while every other atom obeys the what? The octet structure for them to attain stability. If that is clear, you will discover now that we have a single covalent bond between hydrogen and of course the fluorine atom. Remember, I'm using the Lewis structures to describe all of this. Some people may want to use the atomic Bohr atomic model to show the different electrons, but I decided to use the Lewis structures so that we don't make the board, what is on the board, so much that the board becomes clumsy. So we are using the Lewis structure, and because fluorine is a halogen, we're expecting it to have 7 electrons around it. So we have 3 lone pairs of electron and 1 unshared pair. All right. But when it now shares electron with hydrogen, of course, it now has 8 electrons completing its octet. Why this guy? Because they're sharing the electron, now has 2 electrons completing or obeying its duplet. Hydrogen obeyed duplet structure, while other atoms obey the octet structure. Now, the interesting thing is this. Since we have a single covalent bond, remember again, they represent the 2 combining electrons or the 2 share electrons or the 2 bonding electrons. But because the 2 combining atoms don't have the same appetite for electrons, the electrons is going to navigate or spend more time around the atom that is more electronegative. As a matter of fact, in this kind of reaction, in this particular reaction, fluorine is more electronegative than what? Than hydrogen. We're talking about appetite for electron. So fluorine has more appetite for electron than hydrogen. So that way, you discover that the 2 bonded pairs or shared pair navigates or is biased towards the hydrogen. That way, this particular atom acquires a partial negative charge. Of course, this one acquires what we call a partial positive charge. And when this kind of covalent bond is made, we call it polar covalent bond. Why? Why? Because what we produce is known as a polar molecule. I believe it's making sense. The interesting thing about covalent bonding is that there is so much subtopics for us to cover. But again, the beautiful thing is that before now, we have been able to cover some key aspects of covalent bonding. When we talked about how to write the Lewis structures of molecular covalent compounds, we were still talking about a subtopic in covalent bonding. Again, when we talked about hybridization and valence bond theory and molecular orbital theory, those videos are already made and posted on this page and also uploaded on my page. So kindly subscribe to my YouTube channel on Chem Class with Dr. Luther to watch those videos again, as they are all key components of covalent bonding. The interesting thing is this: because we've already treated these topics, it now frees up some spaces that will accommodate some other key issues in covalent bond, because we're not going to leave any stone unturned. Before we ultimately get to the properties of covalent molecules, we are going to make sure that we extensively describe, calculate, and discuss everything that has to do with covalent bonding. I wouldn't want to give chemistry lovers half chop or half meal. I always want to give us a full dose. Again, kindly subscribe to my YouTube channel on Chem Class with Dr. Luther on YouTube. And of course, follow and like our page here on Facebook on Chem Class with Dr. Luther. If some of these things we are sharing is beginning to make your chemistry easy, if you are beginning to find chemistry more interesting, especially for those of you who are disenchanted at the basic level of chemistry, if this is making sense to you, kindly subscribe to our YouTube channel again on Chem Class with Dr. Luther. follow this page, make your comment, leave your comment, leave a kind comment for Dr. Lutan on his teaching style, and share our videos today. Okay? Keep learning chemistry. Until the next time, I remain your humble friend, Dr. Lutan Nokwesili. Stay safe. Okay? And bye.